Percentiles. Remember that a percentile answers the following question. What percentage of scores are below this one? And of course, the score of interest is always abbreviated by the letter X. And when we're using formulas, we're going to use the letter K to represent that percentage. To summarize this question or this statement, X is the number at the kth percentile. We write that as an equation like X equals PK. So we use the letter capital P, which stands for the word percentile. And then, for example, if a number was at the 70th percentile, we would write it as P subscript 70. So maybe these grains of sand in this example might represent students who did some homework, and each data point, each grain of sand, counts the number of hours that a student worked on his or her homework. And let's suppose that maybe this particular grain of sand here represents a female student who took 2.56 hours to complete her homework. And that turns out to be larger than the time for 70% of the other students. So that would place her at the 70th percentile. And we would summarize that this way. Her 2.56 hours is the 70th percentile among the student group. So we can calculate the percentile of a number if we're given a list. If we're given a list with n, we use the letter n to represent the size of that list. So for example, if we have a list with 50 students in it, we would use n equals 50 in that formula. And maybe our particular student that we're looking at is the 36th number in that list when they're ordered from smallest to largest. So we would write L equals 36 for that student. And then we would plug those numbers into this formula. K equals 100 times L minus 1 over N. And that would calculate to give you K equals 70 in this example. So that would calculate that she's at the 70th percentile. We round percentiles to the nearest whole number. You can see that this formula is basically built around just division, the list position over the size of the list. So if a student is like 36th out of 50, it makes sense that that's, she's 36/50ths of the way through the list, so that would be approximately her percentile. We actually subtract 1 from that because we don't want to count her herself. We just count the students who are below her. And then, of course, in the end, we multiply it by 100 to turn it into a percent. By the way, we use 5 or 10% as a cutoff for between the typical scores and the unusual ones. And that can either constitute the top 5% or the bottom 5%. The top 5% would be considered the unusually large numbers, and the bottom 5% unusually small. It's really dependent on the problem. Some problems use the 5% standard, some problems use the 10% standard, and sometimes there are even numbers in between those, but they're usually in the ballpark of 5 to 10%. All right, let's put the pieces of this puzzle together so far to work out an example. Let's see. All right, here we are. A criminal defendant argued that the judge targeted him with an unusually high sentence, 12.5 years. As evidence, he presents a list of defendants convicted of the same crime this year, along with their sentences. Here's that list. So they're ordered from smallest to largest. You can see that the minimum sentence in this list was 5 years. Here's another 5 years, 5.5. And then they range all the way up to the maximum of 15 years. And this defendant, the particular defendant of interest, is highlighted here as 12.5. So how would we calculate that defendant's percentile in this list? All right, here's our percentile formula. My computer is not behaving very well today. Okay, let's duplicate that so we can kind of keep the original in algebraic form and then use this version to plug in numbers. K, the percentile, is the number we're looking for here. L is the size, L is the position of this defendant within the list. By the way, this is a list of 20 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns times 2 rows. So there are 20 numbers in the list, and this particular defendant is the 20th, 19th, 18th, 17th. 17th out of 20. Okay, so the 17 is what we use for this defendant's list position. He is the 17th number in the list, ordered from smallest to largest, out of 20 numbers in the list altogether. Ah, it got smaller. Okay, when we do the arithmetic on this, 17 minus 1 becomes 16. 16 divided by 20 is 0.8. Multiply that by 100 and you get 80. So this number is at the 80th percentile. We could say k equals 80, or we could say 12.5 years is the 80th percentile. Little subscript here in this list. Okay, so that's how we do the basic calculation of identifying the percentile corresponding to a number in a discrete list like this. The follow-up part of the question was, is the criminal, is this an unusually high sentence? Well, by our standards, it isn't, because being at the 80th percentile means that this defendant is at the borderline of the top 20%. But it's really only the top 5 or 10% that would be considered unusually high. So in this case, he's presented a good argument, but it turns out that by this standard, his sentence is actually not unusually high. It's a relatively representative sentence. All right, let's also consider the important flip side to that question. So let's suppose that we started off with a certain percentile that we wanted to target and wanted to find out which list number corresponded to that percentile. For example, what sentence would mark the 90th percentile of the list above? Because that would help us identify the top 10%, for example. Now, this formula basically involves taking 90% of 20. So it would be very reasonable to suppose that we would, since there are 20 numbers in the list, then we could just say, well, 90% of 20 would be 18, so we must be looking for the 18th number in the list, which would be 13. As it turns out, there are some rounding rules and conventions that are really pretty complicated. And for that reason, I recommend that we use StatCrunch to do this, because StatCrunch does the right kind of rounding. So to illustrate that, here's the same list of numbers entered into a column on StatCrunch. So what I'm going to do is go to Stat and Summary Stats and Columns, select Variable 1, and down here you can indicate percentiles, okay? So for example, it says enter 30 for the 30th percentile. So we're just going to type 90 in there to look for the 90th percentile. And I guess we could store that in a data table and compute. Okay, so what it shows us here is that the 90th percentile is actually 13.25. The reason it did that is because, let's see, I guess I have to, I lost my original data. Okay, here it is. It had to, there's a funny rounding rule about, because remember that if you're at the 90th percentile, it means you have to be larger than the 18th number, not at the 13th number. So it basically went halfway between the 18th and 19th number. So it's a little bit weird, but StatCrunch knows how to do the rounding, and I've double checked to make sure that the answer StatCrunch gives us matches the answer key that the homework is looking for. So I'd really just recommend using the technology to solve that particular question.